Okay, good afternoon. So now we're looking at the worksheet. The video was cut at some point, so I'm going to redo the last question from the beginning. And that is dealing with worksheet 15F, correct? The 15F. Yeah. Okay, so 15F. Number? 2.2. Okay, so I'm going to redo 2.2. Okay, so the question says determine the equation of f of x and g of x. Okay, let's take everything off here. So for f of x, it's going to be this equation of this line going through here. Do we have 2 points that this graph is going through? Yes, which is this point here, which is negative 3 and 0, and 0 and negative 2. Not so. At this point, we already know what our C value is. What is our C value? Negative 2. So the equation will be in the form of y is equal to mx plus c. As we said, that c is negative 2, which is your y-intercept there. So how do we work out the gradient? Will be y2 minus y1 over x2 minus x1. If this is x1, that will be y1, x2 and y2. So that will simply be negative 2 minus 0 over 0 minus 3. What do we know about the gradient of f? It will be a positive or negative gradient? Negative gradient. Why? The graph is decreasing. Okay? Or the slope is to the left. So that is simply negative 2 over 3. So the equation of f is y is equal to negative 2 over 3x, and you see value is negative 2. And that is your equation of f of x. Okay? So what do we know about if lines are perpendicular? The product of the two gradients is negative 1. So we know that the gradient of the first line, which is the gradient of f, times your gradient of the second line, which is the gradient of g, must be negative 1. So if lines are parallel, gradients are equal. If lines are perpendicular, as you can see the 90 degrees, the product of the two gradients is negative 1. So this is now for g of x, no? So we have solved for f of x now. What is g of x? G of x is this here. You see there's a g? So that's the line g of x. Okay. So what do we say now? What is the gradient of the first line? What's the gradient of the first line? Negative 2 over 3 times the gradient of the second line is negative 1. How do we get the gradient of the second line? You divide both sides by negative 2 over 3. Can you see that, people? So negative 1 divided by negative 2 over 3 will be 3 over 2. So my equation now reads y is equal to 3 over 2x. And what is my c value here? Negative 2. Okay. Any confusion? Alright. Got the next question. The 2.3. Nope, there's nothing to do. So if you're looking at f, so for f of x, did I put the g of x in the previous one? Yes. Yes, should be g of x is equal to. You all okay with that? For f of x, okay. F of x is the graph going through here. It's going through 4. So I know that, what do we know at this point about f of x? There's a c value of 4. Not so? Why? Your y-intercept. You see is your y-intercept. Not so? But what else? We don't have another point on this graph. We can see it's perpendicular to G, but there's nothing on G either. Not so? However, what we also note is that for f of x is also parallel to that line. Can you see that? So if lines are parallel, what do we know? Gradients are the same, gradients are equal. So whatever the gradient of that line is, it will be the same for the gradient of g of x. Not so? So what is the gradient of that line? 3. So we know that the gradient of the first line is equal to the gradient of the second line, which is equal to 3. So your f of x now reads, and you got the c value of 4. Why? Because that's your y-intercept. So y is equal to 3x plus, and that is the equation of f of x. That line called f. Okay? So if we're looking at g of x, what do we notice about g of x? G of x is perpendicular to f of x. Okay? So this is for g of x. So what's the rule if a line is perpendicular? The product of the two gradients is negative 1. Gradient 1 times gradient 2 is negative 1. That is if the lines are perpendicular. Okay. So what is the gradient of f of x? 3. So it's 3 times the gradient of g, let's call that m2, is equal to negative 1. It's not good to call m1, m2 because these are already m1, m2. But it's just the idea. You guys understand? Yeah? So I divide by 3 both sides. So m2 is equal to negative a third. So what do we say now? Therefore, what is your c value here on g? C value is your y-intercept, not so? And where does this graph cut your y-intercept? At 0. So therefore, your c is going to be 0. My equation is y is equal to negative a third x plus 0. I don't need to put that in there. And this is the equation of. Okay, any confusion there? I'm just checking if the thing is running. No confusion. Let's look at the next one. In question 3 we are told, determine the relationship relating to the input value to the output values shown in the following table. Okay? So what happens here is that you can see we're adding 2 all the time, not so? Okay, so this is arithmetic. Here we're subtracting 4 all the time, again arithmetic. So one of 2 ways, I can either apply what we know about number patterns. We have done number patterns, not so? We could have done apply what we've done in number patterns, or what we did in graphs. Okay? So now in 3.1, together, this makes a coordinate. Remember in coordinate form, we got an x and a y. So what is this coordinate here? 1 and negative 3. And we take another point, 3 and 1. If you have taken 2 and negative 1 and 4 and 3, you're going to get the same answer. Or I take 1 and negative 3 and 4 and 3, I should get the same answer. Okay? But to calculate the coordinate or the equation of this line with the relationship that exists there, I only need 2 points using this method. So remember, this is a x1 and a y1. This is a x2 and a y2. So we got y is equal to mx plus c. How do we work out m? y2 minus y1 over x2 minus x1. So for the gradient, it's going to be 1 minus 3 over 3 minus 1. Put that in the calculator, you should get 4 over 2, which is 2. So y is equal to 2x plus c. Do I know the c value from this table? No. However, from this table, what would the c value be? What would the C value have been from this table? 2. Why? So your X value is 0. Why is your X value 0? Because on your y-intercept X is 0. So we'll substitute the pointers line on this graph. Let's go with 1 and minus 3. Remember again, that's an X and a Y. Okay? That's behind the calculator. Let's move it over. Okay. So that's going to be negative 3 is equal to 2 times 1 plus C. 2 times 1 is 2. Negative 3. Bring it over. Becomes negative 3 minus 2 is equal to C. So C is minus 5. Therefore Y is equal to 2x minus. Yes? Yeah, I thought you were going to ask me something about the maths now. Make quick. Okay? And in 3.2 you do the same method. Y is equal to negative 4x plus 2. Okay? The idea is just to do the odd numbers so that we can get through this worksheet. Okay? Okay, so in question 4, worksheet 15F number 4, on the same set of axes, sketch and label the following graphs. Also indicate the points of intersection of the graphs. So I'm going to do both because there wasn't much of these questions covered. Okay, so the first one is y is equal to negative 3x plus 6. So to sketch this graph, what do? I work out the x-intercept. How do you work out the x-intercept? We let y equal to 0. So we have 0 is equal to negative 3x plus 6. 3x is equal to 6 divided by 3, x is equal to 2. So I'm going to cut my x-axis at 2. Okay? So just by approximation, x will be 2 approximately. Not so. So what do I do thereafter? I work out a y-intercept. What do you do for y-intercept? X equal to 0. So we've got y is equal to negative 3 times 0 plus 6, which is 6. So it's 2, 3, 4, 5, 6. Can you see that, people? So the graph is going through 6 and 2. Okay. You want to agree with that? Right. Label it. We need to label. We then say y is equal to negative 3x plus 6. Okay. You all okay with it? Let's look at the other graph. Let's take this off here. Because I need the space. Now the equation is y is equal to x plus 2. Again, x-intercept, what do we do? Let y equal to 0. So 0 is equal to x plus 2. So for x is minus 2. So it's going through here. That's fairly close to each other. Right. Then what do we do? Y-intercept. What do you do for y-intercept? With x equal to 0. So y is equal to 0 plus 2, which is 2. It's going through there as well. Where we draw, the graph is coming through there. Again, they want to label the graph. So that is the graph of y is equal to x plus. Can you see that, people? Now if they let this be f of x equals negative 3x plus 6 and g of x equals x plus 2, then instead of saying this whole thing here, I could have just said f and I could have just said g. You guys understand? And that is your another way of representing your functions. Right, you guys understand? Any confusion? No. Then the second part of the question says, I'm going to do this in green. Again, I need space here. The question says, the point of intersection of the graphs. Where do you see the point of intersection? There. So according to the graphical representation of this graph, it looks like the point of intersection is actually 1 and 3. But I could be wrong. Why? Because the diagram is not drawn to scale. So how else do we how else do we work out the points of intersection? We've done it in first term. And you were tested on it as well. We do simultaneous equations. You guys remember? Simultaneous. So how do we work this out? Because the one equation is y is equal to x plus 2. And the other equation is y is equal to minus 3x plus 6. What we do is at this point, the two graphs are equal to each other at that point. Okay? So if we see the two graphs equal to each other, if there's a y, if y is equal to x plus 2, and y is equal to negative 3x plus 6, then in other words, x plus 2 has to be equal to negative 3x plus 6. You see that, people? Like as if you're saying A is equal to B and B is equal to C, what can we conclude? Therefore, A has to be equal to C. Yes. If you got A is equal to B and A is equal to C, then B has to be equal to C. On that same account, I'm applying if y is equal to x plus 2 and y is equal to negative 3x plus 6. Where are they equal? They are equal when x plus 2 is equal to negative 3x plus 6. Okay? So, we bring that over, that over. So we're going to get x plus 3x is equal to 6 minus 2. X plus 3x is equals 4 divided by 4, x equal to 1. Which now confirms that is correct. Okay. How do I calculate the corresponding y value? I can sub that either into the first one or the second one. So y is equal to 1 plus 2, which is 3. Therefore, the point of intersection is where? At 1 and 3. Okay. Does it make sense, people? Okay. I think I should do the next one as well. No? Let's take this off. Right, 4.2. Equation 4.2, same story. You just sketch the graphs first. So y is equal to negative x minus 3. So what do I calculate first? The y-intercept. We let x equal to 0. So y is equal to negative 0 minus 3, which is negative 3. If I draw the graph, it's 1, 2, oops. There's negative 3. Okay. It's going through negative 3 there. And then now x-intercept, what do you do for x-intercept? Let y equal to 0. So 0 is equal to negative x minus 3. X is minus 3. Again, what do we do? We draw the graph, ruler line. And they want us, of course, to name the graph. So that is y is equal to minus x minus 3. Are you all okay with that?
Yes, sir.
Oh, it's linked. Okay? So I'll put that now down. But okay, it's fine. Remember, that's your y and this is your x here. 0. So what do we do here after? Now the equation. So we say the equation is y is equal to x plus 3. So, x-intercept, what do we do for x-intercept? Let y equal to 0. So 0 is equal to x plus 3. So x is equal to negative 3. X is negative 3, which is this point here. That's right? Then we do y-intercept. What do you do for y-intercept?
X equals 0.
X equal to 0. So y is equal to 0 plus 3, which is 3. So it's 1, 2, 3. The graph is going to go through that. And this is the equation y is equal to x plus 3. Do I have to work out the point of intersection, or can we read it off the graph? Read it off the graph. So what is the coordinates of the point of intersection? What's the coordinates of the point of intersection? Negative 3 and 0. That is for the point of intersection. Okay, any confusion? No. Moving too slow? Okay, I'll try and work a bit faster. Okay. Right! 15G. 15G. The question says find the equation of f and g and the coordinates of a and b. Okay, so this is the axis here, no? The axis. X-axis and the y-axis. Okay. So if this is the line f. What is the equation of f of x? Spoke about this in the previous lesson. Is it the x or y? All the learners that took note left. X or y? Oh, y. How? Who can tell the y? Why? So that's parallel to your x-axis. Anyway, on this graph, it has a constant reading of y is equal to negative. Okay, anyway, on that graph, you will have a y value of negative 4. How do I know it's negative 4? Is that there? If the graph had gone through like this, parallel to your x-axis, to your y-axis, then x is equal to 6. Can you see that? Right. Just take off here again. So what's the equation of f of x? F of x equals y equals negative 4. Why? Because that's a y reading. So how do we calculate g of x? What do we need for g of x? We need 2 points on the graph. We have 1 point. And what is this point here? The coordinates of that point? 3. What? What's the coordinates? Not what, as if you don't know what I'm asking. 0 and 3, yes. So the coordinate of A is 0 and 3. So there I got A already. I got F. Do I have another point on this graph? Yes. Which is? 2 and 0, yes. So how do I calculate the equation of a straight line? Y equals mx plus c. How do you calculate m? y2 minus y1 over x1. So if this is x1, y1, x2, y2. So we have 0 minus 3 over 2 minus 0, which is negative 3 over 2. Okay? Do we have the C value? What's the C value of this of the g of x? What is the y-intercept? 3. Your C value is 3. Why is it 3? Because that's your y-intercept. So y is equal to negative 3 over 2x plus. So we got g of x. So what still needs to be calculated? B. At this point, what do we know about B? B's coordinate. What do we know about B's coordinate already? What did we say anyway on this line of f? X is negative 4. Not x. Y is negative 4. Can it be 0? No. If it was there, then it would be 0 and negative 4. No. 0 and negative 4 is here. That's 0 and negative 4. So it's not that. Do we know the x value here? No. So since this point is lying on the graph of g of x, can you see that? So what I'm going to do is I'm going to substitute b, which is x and negative 4, into g of x. And there I got already the equation of g of x. Remember when I put the x in, I get the corresponding y out. If I substitute the y in, I get the corresponding x value out. Not so? So this is the x and the y. So you're going to say that's your y, negative 4 equals negative 2 over 3, and x remains x plus 3. Firstly, before we calculate x, we know that the x value is going to be positive. Can you see that? So we take this over the equal sign. It becomes negative 4. No. Negative 4. I'm going to take the 3, but it will become 3 over 2x equals 3 plus 4. Not so? What's 3 plus 4? 7. It looks like you guys will pass. Okay. So you're going to divide by 3 over 2 both sides. So x is equal to 7 divided by. Or you can just substitute in your calculator. Not so? Substitute in the calculator. So we say 7 over, we divided by 3 over 2. And I give you 14 over 3. Or we could have said 7 divided by 3 over 2. Like that. Also get 14 over 3. Okay. But have I answered the question? What is the question? The coordinates. And what's the coordinates of B? 14 over 3 and negative. Okay. The sum like this is worth 4, 5, 6, 7, 8, 9. About 9 marks. Yeah? So watch these videos again. Make sure you understand what's going on. Okay. Let's go with number 2. Find the equation of the straight line of f and g. Okay, I'm just going to move this down a bit. Find the equation of the straight line f and g. So if you're looking at f of x, if you're looking at g of x, we can't calculate g of x first. We only have one point on the graph. We don't have the gradient. Okay? We're looking at the graph of f of x. It's going this graph here. Do I have 2 coordinates on this point? Known coordinate. The one being Negative 2 and 0 is? And the other one? 0 and 4. That's the two known coordinates. The other one, A and 8, is not, we don't know A. And negative 4 and B, we don't know B. You guys understand? So I must work with a coordinate that is known to us. Okay. So, for f of x. You don't have to write this. This is just that if you're a bit confused, what we're calculating at that point. Okay. So, for the straight line, it will be in the form of y is equal to mx plus c. How do you calculate m? y2 minus y1 over? Do we, so, the coordinates here that we have is 0 and 4 and negative 2 and 0. So again, if you make this x1, that's y1, x2, y2. So I got 0 minus 4 over negative 2 minus 0, which is simply 2. And you see the graph is lying to the right. There's a positive gradient. Okay? Do we know the c value of this graph? Yes, you got the y-intercept. And your y-intercept is 4. So therefore c is equal to 4. This figure is behind the curtain, it's fine. C is equal to 4. So my equation of f of x is then y is equal to 2x plus. You guys understand? So I'm going to put here f of x. Okay. So do we have enough information to calculate g of x? Yes. Look at g of x. We have one point, which is 0 and 4, which is also your c value, not so? So your c value is for y, c4, so that's your y-intercept. Okay. However, we know that g of x is perpendicular to f of x. So what does that mean to us? The product of the two gradients is negative 1. You see, it's the same thing being repeated all the time. Just different values being used. Okay? There's quite a bit of marks on this in your exam. Did you guys see the scope?
Yes, sir.
Quite a bit, no? Don't waste your time. So what's the gradient of the first line that you have? What was the gradient of the first line? 2, yes. So it's 2 times the second line equals negative 1. To get the gradient of the second line, you get m2 on its own, which is negative 1, yes, over 2. Okay. So what's my equation? Y is equal to negative half x plus c. And my c value in this case is 4. And this is your graph of g of x, your equation of g of x. Make sense, people?
Yes, sir.
In the next question, I put this g of x here. Oops. Okay. I think I'll just write it here. If needed, g of x is equal to negative half x plus 4. If we need it, it's 2. Okay. Right. So in 2.2, I use blue, it's called. In 2.2, the question says determine the values of a and b. Lowercase a, lowercase b. So where do you find a? It's there. Not so? That coordinate is a and 8. Not so? So what we're going to do is, remember, if we substitute, okay, a and 8 lies on which graph? Lying on the graph of f of x. Now remember, if I put the x in, I get a y out. Or if you put the y in, you get the x out. Not so. So what I'm going to do is I'm going to substitute. a and 8 into the graph of f of x. Why am I not going to go and substitute into g of x? Because it does not lie on g of x. Okay, you understand? So remember again, this is x and a y. So f of x, this here is your y, and there's your x. You guys understand? So we have here y, I put a 8. So 8 equals 2 times what your x value? A plus 4. So what do I do now? Solve for x. Or a in this case. Take it over. So it's going to become 8 minus 4 is equal to 2a. What's 8 minus 4?
4.
4. Okay? So 4 is equal to 2a. Then divide by 2 both sides. So a is equal to 2. So there we got a sorted out. Okay? So now, for b, to calculate b, where is b on? It's a coordinate on f as well. So can I substitute it into g of x? No. You can only substitute it on the line in which is lying on. Not so? So we're going to substitute negative 4 and b into f of x. Again, people, this is your y and that is your x. Again, this is your x and a y. So what's your y value? b is equal to 2 times negative 4 plus 4. 2 times negative 4 is negative 8 plus 4 is negative 4. Here I got my a and my b value. Any confusion there? It's easy to see somebody else do it, no? It's just when you do it yourself is the issue. You guys will keep on practicing these things, okay? Number 15, G. Okay, we've got 2 minutes left. So, 2 sums we can do in this time. Not so?
Yes, sir.
Okay, I think we're going to start this with our next lesson, which is tomorrow. Okay. So enjoy the rest of your day. Guys, may pack up.